Hi guys, welcome back here at the EC Engineering Tutorial. So continue pa rin tayo sa discussion natin under Irrigation Engineering. Okay, so we have measurement of soil moisture. So drilling holes and obtaining soil samples. So ito yung ginagamit natin. We have the soil auger, hand soil sample tubes and probes, and power auger tubes and probes. Yan yung ginagamit natin na equipment. So in drilling holes, we have spiral shape na bit soil auger. So ganito yung ginagawa natin sa farm, no? So we use this spiral shape na bit soil auger. Okay? And we have also this post hole bit soil auger. Ayan, no? So ito yung itsura ng post hole bit soil auger. So in obtaining soil sample, so we have these hand soil sampling tubes and probes and parts. So we have this dismantled assembly for vertical soil core sampler with all necessary parts. And we have this mounted vertical soil core sampler with all the pieces assembled in their correct position. And we have this large vertical soil sampler which is around 60 to 80 centimeter long. And we have this hardened steel cutting head of the vertical soil core sampler screwed to the tube of the sampler by rough threads. And then we have this soft aluminum cup to protect the vertical sampler from the blows from the heavy hammer. And we have this compactor to help extract the soil core from within the soil sampler and maintain the integrity of the core in the light soil. And we have this one, no? A U-shaped jaw accessory mounted on the car jack belt to fit the cutting. So ito yan. Cutting head of the soil sampler. So this allow easy lifting of the sampler from the soil. And we have this a flat strong steel base welded to the base of the jack of the car jack to prevent the car jack from sinking into the ground during extraction. And we have this assembled short soil sampler which is around 40 to 50 centimeter long. So the methodology is the vertical soil core sampler is inserted into the soil using a heavy hammer. So when the soil is hard or dry, a large hammer is required to insert the soil sampler. And if soft sandy soil, a smaller hammer is needed. So the handles are used to maintain the vertical penetration of the sampler without risking injuries to the assistant. So parang ganito, no? Nakikita natin sa picture. And then the soil sampler is completely inserted into the ground in about 1 to 2 minutes. And the soil sampler is completely inserted in the ground in about 1 to 2 minutes. Yan na yun, no? So using the car jack, the soil sampler is easily retrieved in about 2 minutes. And then, ayan. So using the car jack, strong workers are not required. So using the car jack, the soil sampler is easily retrieved in 2 minutes. So ganun pa rin. And the soil core is placed in a plastic bags that are delivered for laboratory analysis. And this is the example of the extracted soil core, no? Nakikita natin sa picture. And we have this example of extracted soil core. So ito yun. Okay, so that's it for obtaining soil samples. So we have also power auger tubes and probes, such as shown here. And we have this different measurement of soil moisture. Okay, so the soil moisture measurement methods. So measurement of soil water is very important for many studies related to water management, including the irrigation scheduling, no? But it is not a simple process. So several methods have been proposed, and each method has its own advantages and disadvantages. So some of the methods used is ito, no? We have direct methods, which is gravimetric method and volumetric method. And we have this indirect method, which is electrical resistance block, neutron scattering technique, the TDR, the time domain reflectometer, and the tensiometer. And we have also this feel and appearance method, no, used for mga veteran, no, mga hawd na jud gayo. So in the direct methods, we have this gravimetric method. So the gravimetric method is a standard direct measurement of soil water by which all the indirect methods are calibrated. So this method involves collecting soil sample from the field using auger and determining its moist and dry weight. So the moist weight is determined by weighing the soil sample, the MS, as it is at the time of sampling, and the dry weight is obtained after drying the soil sample in an oven at 105 degrees Celsius for about 24 hours, no, or 1 day. So the weight loss represents the soil water, or the MW. For the volumetric method, the volumetric water content is defined as the volume of water present in a given volume, so usually 1 cubic meter of dry soil. So this method involves collecting soil sample from the field using a core sampler of known volume from representative depth in the root zone, and then determining its moist and dry weight using similar process as in case of gravimetric water content method. So the difference in weight and the dry mass of the soil represents the amount of water in that sample. So the volumetric wetness can then be calculated as follows. So we have this formula, which is the mass of water over the volume of core times the density of water times 100, no, to convert it into percent. So to calculate the volume water content from gravimetric water content, we need to know the bulk density of the dry soil, and is calculated as follows. Okay, so the depth of water in millimeter per unit depth of soil, the DS, is calculated as follows. So we have here an example. A moist soil sample collected from the agricultural field weighs 120 grams. So when it is dried, the soil weight is 100 grams, and the density of soil is 2.4 grams per cc. No? So we need to calculate for the gravimetric moisture content and volumetric moisture content of the soil sample, given yung depth ng water present in the soil, as the depth of soil is 75 cm. So first, we need to compute for the water mass, which is the difference lang ng moist sample and dried sample. So we have 20 grams. And using this formula, we have MW over MS. So yung mass ng water, we have 120 minus 100, or 20 grams, divided by yung weight ng oven dry natin, which is 100 grams. So multiplied by 100, we have 20%. No? And using this formula, we have 4.8%, given yung 2.4 grams per cc. So bali yung depth ng water in mm per unit depth ng soil using this formula is 36 cm. So another example is a soil sample has a weight of 0.7 kilograms. So after drying out, the weight was reduced to 0.6 kilograms. So bali, yung mass ng water is yung difference ng dalawa, 0.7 minus 0.6. And the particle specific gravity test give a 2.6. So yung required is the moisture content using this formula, like plug and play. So we have 14.3%. Okay. Another example, a soil sample taken from a field is placed in the aluminum box, weighted and dried in an open at 105 degrees Fahrenheit, and reweighed. So the measurement are as follows. So bali yung weight ng moist soil plus the aluminum box is 159 grams. Yung weight ng oven dried soil plus the aluminum box is 134, and tsaka yung weight ng empty aluminum box is 41 grams. So we need to calculate for the moisture content of the soil. So to calculate for the weight of moist soil only, so we need to subtract itong aluminum box na. So 159 minus 41, we have 118 grams. For the oven dry, we need again to subtract the weight of the aluminum box here, no? Which is 134 minus 41. So we have 93 grams. Yung difference ng dalawa, yan yung weight ng water only, no? So we have 118 minus 93 divided by the weight ng oven dry natin, which is 93 times 100. So we have 26.9%. Okay, so we will be discussing in the next video the indirect methods. Okay, so see you in the next video.